it's Jay here. I'm down in the shop and I want to talk about lighting. Doing these videos has kind of shown me that I had let my lighting system in my shop degrade over time. When I originally designed it, this shop had fantastic lighting and I was super happy with it. Over the years, the fluorescent lights have sort of worn out and things have gone bad and I didn't quite have bulbs in every socket. So I just kind of had to redo that to keep from getting grainy video. But it's also just so much nicer down here now. And one of the criteria I think of when in a woodworking shop for lighting is if I take a piece of walnut and I draw a line on it, I should be able to see it where I need to see it. So I took a light bulb out because there's so much glare on this whiteboard, but if I hold it forward, you should be able to see the line right there. When I bring it back in here, it gets a little harder to see because I have that one bulb out that's sort of making my head not shine. So there's a few things when you set out to design a lighting system for your shop that you need to consider. One of them is the quantity of lighting, and according to literature that should be 20 lumens per square foot. And there are calculators out there that tell you, like, if I want to use this type of lighting fixture that puts out this many lumens, I have this many square feet, here's how many of those lights you should have. They're available everywhere. If you just do lumen calculators or lighting calculators online, you should be able to find them. One of the things you have to think about when they ask you the ceiling height is you want, in a wood shop, at least you want the height to be the height of your workbench and not the height of the floor. So that's one thing, so that it'll group the lighting closer together. The next thing you need to think about is lighting quality. And there's color temperature and color reality, called CRI. Color temperature you know of, it's cool light versus warm versus daylight versus sunlight. And that is the standard lighting that you buy. I prefer 5,000 degrees Kelvin, so everything I'm talking about here is going to be 5,000 degrees Kelvin. The temperature is a measurement of something burning at a certain temperature, and 5,000 degrees Kelvin is the lighting that comes out. So that's called daylight by all the manufacturers. Color reality index is a more strange one. They measure the reflectivity of different colors, or the quantity of different colors in your lighting over the spectrum, and they give you a reality of that relative to how much of each color is in sunlight or outdoors or whatever. So you might have less red, you might have more blue. The best thing I can talk about with that is it's similar to your monitor. If you don't have your monitor set up right, or somebody took a bad picture that has bad color, you wind up buying a shoe that shows up as red, that's on clearance, and you wind up with a shoe that looks like this, that's, I don't know, pink or salmon or something, but it's comfortable enough to wear anyway. So that's CRI, and most of the lighting that I have is greater than 80, which isn't great, and I'll talk about that more as I'm putting up lights. And then finally, concentration, where you put the lighting. And I kind of drew a picture here of, there's two lights here and a workbench, and you can see the lighting kind of comes down. And I used 45-degree angles when I did my layouts for the lighting, because I think the vast concentration of brightness is within a 45-degree angle on a fluorescent fixture. So that's what I used as my, to make sure that my lights were overlapping enough at benchtop height. And then, big one's money. Most of the YouTubers who do lighting things go, wow, I'm going to put up new lights in my shop, and they have a sponsor them for $10,000 worth of lights, and they have a control panel and all this stuff that's all different colors. I'm not doing that. This is how can I get almost that good of lighting for a couple $100. And that's what I'm trying to do in my shop. That's what I've done in my shop in the past, and I'm going to do that to my garage right now. So there's two things in this video I'm going to do. I'm going to fix the lighting in my shop and bring it up to date and make sure that all the bulbs have are lit. I'm always a bulb or two short of a full pack, but then I'm going to do the garage, and my garage has horrible lighting, and I'll show you that, and we'll upgrade that. It looks great now, so here we go. So here's the problem I had with my shop lighting. You can see here I had these old garage type fixtures that they sold for like $10 a piece at the big box stores, and most of them had one bulb in them. Some of them had two bulbs, some of them were fluorescent, some of them weren't. When I first designed the system, they all had really high quality 5000K daylight bulbs with a 93 CRI, which is a really high number. And the lighting was fantastic in the shop. But you can even see, I don't know if you can see it on the video here, but that one fixture in the back right that does have two bulbs has the original nice fluorescent bulbs. It buzzes like crazy right now. And but they're not the same as they were. Those bulbs have worn out over time and they aren't putting out nearly as good a light. Most of the other fixtures have been converted to LED because they've died over the years, and they are suffering still from problems. So the goal is to get bulbs in every socket and to convert all the lights to LED fixtures. This light fixture right here is still fluorescent, and those are some old fluorescent bulbs in there. They were really good fluorescent bulbs back in the day, but I think right now I'm going to replace them, and I'm going to replace them with these, which are a new type of LED bulb. And it's not really a new thing. These have been around for a while. These LED bulbs that you plug in and you take out the ballast in the fluorescent and you just connect everything to regular 110. The difference with these is they have these switches on them, and the switches control the brightness and the color temperature. So you can get up to 24 watts, from 10 to 24 watts of actual power, and then you can run from 3000K to 6500K color temperature. So I've been setting the color temperature down to 5000, and I think I'm going to crank these ones up to about 18 watts because I'm going to put two of them up there, and we'll see how that goes. And if it's not bright enough and I still struggle, I will crank them up even higher. Over the years, I've been in and out of these fixtures quite a bit. At first, it was to replace the ballasts as they went bad, and then I started converting them to LED. This one has an original ballast. It's one of two as I went through and did the final conversions of all these light fixtures. These two survived 22 years. Not bad for a $10 fixture. One of the things I've been doing is marking which side is hot. This is the black wire, and I just put a little red on here. Can't really see it. Nobody notices it, but these bulbs that I just bought actually care, and they only go one direction. Most of the bulbs go either way, but these particular ones, you have to put the switch side on the hot side. Most of these conversion bulbs have different ways that you can wire them. I've chosen to wire a hot side and a neutral side, where one whole side of the bulb is hot and the other side's neutral. They also support one pin on either side being hot and neutral, but I've chosen this because the original bulbs I got used this methodology, and I keep my whole shop consistent. After replacing all the bulbs, this is what I wound up with on the one side of my shop. And you can see the layout I originally used. I have 3 rows of lights that were all here, and the one fixture in the back I've just left dead because it is just covered with my plywood rack. In the main part of the shop here, you can see I generally have 2 rows of lights, and then I have a bunch of things that were hanging down in the ceiling, because this is a basement, that keep me from having a nice flat ceiling. So you can see the side over here where I have a bunch of can lights, and then all the rest of the lights are in 2 rows, and I still have the light bulb out from when I was filming earlier. So you can see that one hanging down, but the lighting gets interrupted by both plumbing and also some of the dust collection routing that I had to do. So part of the reason that I have my lighting set up in a way where it plugs into sockets in the wall is so that I can move it around. Another reason is for the soundproofing, and I will talk about that in a different video, soundproofing your basement video, because this is a basement shop and it needed that as well. So that basically takes care of the lighting in the shop, and now we're going to move on to the garage. All right, well, the garage video is going to be grainy. It's the only way I can get enough light to even register things in the garage. You can see I've been using these, I don't know what you call them, light petal light or flower petal lights or something like that, these LED things that you can buy. And they don't last very long. You can see that one's sort of got a few dots that are showing up, but there's not much brightness to it. And that's what happens after about 6 months of being in my garage. And they're about 40 bucks a piece. So I have a whole new lighting system ready to go in here. I finally have a weekend day to take care of the garage. So first thing I need to do is move the cars out, and then I can get moving on the garage lighting. Well, the race car had other ideas. It's angry at me for not using it recently, so it didn't want to start at all. The battery in it is pretty shot. I had to figure out how to get my jump box to bypass the fact that there was even a battery there, take it out, because I think it was actually causing problems with the thing. But even once I got the motor spinning, I don't think the jump box was ready to take care of business there. So I knew when I took my window out and stuck it on that little cart that it was a bad idea. And sure enough, I almost knocked it off with the door. But come on, you can do it. It's going. So it's time to get out the ladder and get to work. This ladder winds up being about 9.5 feet when it's fully extended. So you can see the ceilings are pretty tall. I have a bunch of bike racks and garage door stuff in the way, as well as some other stuff in the ceiling. So it's going to make it a little difficult. I'm using these 8-foot tubes, and you can see me waving one of them around to sort of start to get a layout together and realize how much stuff is going to be in the way that's on the ceiling. So these things say to connect no more than 4 in series. They give you these 2 types of electrical connectors. So this type has the end that goes into the light and a blank end. They give you a bunch of those, and then they give you a bunch of these longer ones that have 2 ends for series connections. So I think my plan is, as you look up here in the ceiling, is to do two 8-foot sort of squares, one on this side and another one on that side, and I'll attach the connectors to where those light bulbs hang. Now they give you these little clips that you're supposed to clip them in. Let's see how many clips they give. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. So 42 for 10 lights. So they're expecting 4 of those per light. What a pain. I ultimately decided I was going to use 3 clips per light, one in the center and one 3 feet on either side. And so I made one of the bulbs a story stick. I'm going to take that bulb up and make the marks on the ceiling to install the clips. I figured out the ceiling has some fire resistant stuff behind the drywall, so I can actually just screw them right in and the screws hold really tight. That made it a lot easier. I didn't have to use any kind of drywall anchor when I was installing the clips. But it's now time to step and repeat and step and repeat and get this done. As far as quantity of light goes, the manufacturer claims 15,000 lumens for these lights, and I'm assuming that's for the entire pack. I don't think a single bulb would do that. But there's 10 of these lights at 1,500 each, and I'm gonna wind up installing 8 of them in this round. So that should put me pretty close. The lumen calculators calculated I need somewhere around 9,500 lumens for a garage of this size with a ceiling height like that, in order to have a reasonable lighting in the garage. I did a lot of wiring, screwing around, trying to get a permanent wiring solution in place, but it turns out the boxes in the ceiling were pretty bad, and really all they could do is hang one of these light fixtures. So once I got the wiring correct, on they went. Now it's on to another step and repeat. Doing each of these other bulbs. The CRI on these bulbs says it's 80 plus. They'll be fine. I'll be able to tell that my car is red and that different parts are not. So I think that's going to be okay for a garage. The other side of the garage wasn't quite as cooperative. It's not symmetric, so there wasn't quite as much room for this final light, and it was running into the wall on one side and the light fixture on the other side, so there was no space for the light harness to go on it, so I had to actually put a spacer and space it out from the ceiling a little bit to make it fit. Alright, here's the finished garage. I kind of tied up all the cables real nice. I've got 8 lights up there. I may eventually put a light underneath there on this side where I work on cars, but otherwise it's way better. A lot more light. I can see how dirty the car is now. All right, I've also got a bunch of task lighting around in the garage and in the shop as well. Right here you can see I put some of the stick-on lights on a piece of wood with a piece of metal flashing on it, and it creates a little area there that I can flip on and light up my workbench in the garage. I've also put some specific lighting on tools that need it. You can see here a little magnetic LED light. Really nice on the bandsaw when I need a little bit of specific focused lighting. And then I also have on my grinder, it came with a light built into it. And my drill press also comes with a light built into it, and those things I use fairly often. Alright, so the bottom line is I've got much better lighting now. The cost of each thing is the bulbs in the 4-footers that I have in the shop here generally cost $10, $11, $12 per bulb, but there is a DOA cost to those as well. When you get I was buying them by 6 or 8 packs, and about 1 in 10 is dead. And you know, the hassle is you can either pack it all back up and return it to Amazon and try to get another pack, or you just suck it up. So I think there's about a $2 extra charge. There's about 1 bulb difference, so I'd say they're $13 a piece maybe when you count in the DOA average. And then the 8-foot ones that I put in the garage, which are pretty nice, are about 20 bucks a piece. But for number of lumens, they're not quite as good for their size. So I think these bulbs that I got overhead here are almost 3,000 lumens out of a 4-footer, and those bulbs I think are about 1,500 per 8-foot. So not quite as good, but they're a really nice way to light a really big area pretty well. I went to Lowe's and I bought some GE bulbs that are supposed to be the conversion style bulbs. They call them they say installs without ballasts. Direct wire is what they're calling them. They didn't work. So either it's 2 DOAs in a box, so they slammed them around or something, or they're just not good. So they're about the same price if you can figure out how to make those work. So total cost to me has been about a couple $100 for the shop and a couple $100 for the garage. That's over the course of, I've been doing that for buying bits and pieces here and there for almost a year now, making this video. So thank you for watching, and please subscribe if you have any more interest in, I'm doing a whole series on basement garage stuff right now, and that'll all be out next month. So thanks for watching. So here we go. Lights on, no, nothing. Lights on.